Welcome! Today we'll find the volume of a solid of revolution formed by revolving the region bounded by y equals x squared and y squared equals x around the x-axis. Let's start by graphing these curves. First, we have y equals x squared, which is a parabola opening upward, and y squared equals x, which we can rewrite as y equals plus or minus the square root of x. This is a parabola opening to the right. These curves intersect at 2 points. Let's find them. When y equals x squared and y squared equals x, we can substitute x squared squared equals x, or x to the fourth equals x. Therefore, x to the fourth minus x equals 0, or x times quantity x cubed minus 1 equals 0. So x equals 0 or x equals 1. The region we're revolving around the x-axis is bounded by these curves from x equals 0 to x equals 1. Let's shade this region. When we rotate this region around the x-axis, we'll get a solid where each cross-section perpendicular to the x-axis is a washer. To find the volume using the washer method, we need to subtract the volume of the inner cylinder from the volume of the outer cylinder at each point. The formula will be pi times the integral from 0 to 1 of r squared minus r squared dx, where capital R is the outer radius given by the square root of x, and lowercase r is the inner radius given by x squared. Let's solve this integral. Integrating x minus x to the fourth, we get x squared over 2 minus x to the fifth over 5, evaluated from 0 to 1. When we plug in 1, we get 1/2 minus 1/5, and when we plug in 0, we get 0. Multiplying by pi, our final volume is 3/10 pi cubic units.